screen so that you guys can see it. Okay, let me know if you cannot see my screen. Then if you cannot see it, you need to log out and rejoin, or if you guys called in, then you won't be able to see the screen. You have to be using a device like the app. I don't know what that means. Okay. Anybody else not able to see the screen? Okay. So if you're looking at our March calendar, week 2 work, not everything is posted yet, so be patient. I'm going to do that right now. You've got the Ed puzzle. That was posted already, so you guys should have been able to access that first thing this morning. I just posted the horse leg lab and the horse video, so that one's on your Google Classroom now. I'm about to post the evidence for evolution POGL. I'm going to post the phylogenetic trees POGL, and then your vocab, I'll talk to you about that in just a second, but the next 3 words are going to be do. So if you come over here to Google Classroom, one thing that I want to make sure, because a lot of people are not doing this, I posted this code of conduct, the distance learning code of conduct. I need everybody to be turning this in. This is not in a topic, it's just at the very, very top of our classwork. Please do the code of conduct. Otherwise, I'm going to be forwarding your names to our administrators. Oh man, I posted this in the wrong one. Hold on. Why are there 2? It's annoying. Okay, let's talk about this activity. In an ideal world, we would be doing this in our classroom, but of course we're not. So I had to modify it and give you guys some of my work so that you could analyze it. So usually what we would do is we would be graphing this information. So I went ahead and I did the graph. So this is my x-axis, which is millions of years ago, and then the teeth span. And what they're looking at when they talk about the teeth span, they're talking about how wide is it from the back of the very last tooth to the front of that, not the front teeth, but those side teeth. So that's what they're looking at, is teeth span. So we're graphing that. And what we're looking at is how have the teeth span sizes changed over time for our horse ancestors. So if you look millions of years ago, so 72 million years ago, we've got the Eohippus. The teeth span was at, what is this? Just over 4 centimeters. That's tiny. So if you look at the horse, this is like our modern day horse. I can never say this right. Akis. You're looking at the most current horse species, and now the teeth span is almost 18 centimeters. So over time, you see, hopefully, based on this graph, although I should have done it the other way around so that my oldest horse was over here. But you can see that there's been a significant increase in the teeth span. Right now, for those of you that are on here, can you guys give me any kind of reason that we might have seen teeth span change over time in the horse species? Give me your best guess. Why do you think the horse teeth span has increased over time? Yeah, their food changed, right? So as food within its environment was changing, those horses that were most well adapted to the environment were the ones that were able to survive and reproduce, right? But the ones that didn't have well adapted teeth to eat the food available, they're the ones that are going to die off and they're not going to be able to survive and reproduce. So there's the graph right there. Also, if we were in class, you guys would be responsible for doing this coloring, but because we're not, I colored them in for you guys. So now you'll just be able to analyze them. The one thing I do want to point out, and it's really annoying, up here at the top, it says Z, like zebra, that's a yellow. And all of these W bones, that was my green. So you can barely tell the difference between them, but just know the yellow is the Z bone and the green is my W. It does tell you down here. Toe bones are red, foot bones are blue, ankle bones are light green, and then the heel bone is yellow. All right. So you guys are going to be filling in your data table here. And previously, we would have been measuring these out in class. But again, because I'm not sure what kind of instruments you guys have access to, and I don't want you taking incorrect measurements, I did these measurements for you. Okay. So this is older horse species to newer horse species. So again, if you look 10 millimeters, and obviously horses are not really 10 millimeters, but we're measuring them out based on these little black legs here, because what we're doing is we're looking at how have the horse legs changed over the millions of years. And you can see for sure that the toe bones have changed, the leg bones have changed, all of that, and they've gotten longer. So our measurements are just showing you what this picture is showing you up here, okay? And then the length of the teeth. We already looked at teeth span, but now look at the length of the overall teeth. So this part here is the root. That's what's like embedded in the gums. But you can see how they've changed shape and size over time. So you guys should be able to analyze those graphs, the coloring, and all that. And again, this is just kind of a visual representation. And then there's a short article on here about the evolution of the horse, and it's got some after reading questions that go along with it. Okay. There is a video that was posted that goes along with it. It's only 2 minutes. I would suggest that you guys watch that first and then complete the activity, and then you can move on from there. You're going to need to be patient with me because I am going to be posting these assignments as I show you. The next assignment is going to be the POGIL that's on homologous structures. This was what we talked about just the other day when I went through the notes with you guys. Homologous structures are the ones that are same structure. Remember, homo means same. So same structures, same bones, but different what? Right now in the little chat, tell me, what do they have different? If the bones are the same, what's different? Date, April 2nd. Let me see. Yeah, function. Good. I got a few people that are listening to me. Not a whole lot. So homologous structures are showing you that you've got the same bones, but totally different functions. And that's because at some point we all evolved from a common ancestor, which is pretty hard to believe that we shared any kind of common ancestor with a bird who's avian and flies and a whale who's aquatic and is in the water. But if you guys remember from that whale video, whales actually were land dwelling at some point, right? So, okay, let's see. So our POGIL that I just posted looks like this. And you've got this chart right here that shows you the number of the bones. And I know that you guys don't know all of these bones by heart, but your humerus is the top of your arm. And then in your forearm, you've got two bones. This white bone right here, the one that's on your thumb side, this is going to be your radius. The red bone on your pinky side is the ulna. The little yellow bones, we have 8 of them that make up our wrist. Those are the carpals. And then in our hands, the long part of our fingers, those are our metacarpals. And then finally, the finger bones, those are called phalanges. So hopefully you can kind of, I would recommend that for study purposes, you guys try and label them, because not that you have to have the bone names memorized, but it's going to help you out when talking about homologous structures. Okay, so you're going to fill in your answers there. And then also down here, the other thing that they're talking about is look at these organism pairs. Let's see if I can zoom in. Organism A and B. it says they have 97% of their DNA is similar. Organism A and C have 85% of their DNA that's similar. And then organism A and D, they have 50% of their DNA that is similar. So, based on that little data table, which organisms do you think are the most closely related? Give me some answers. I want to know which organism is most closely related to organism A. Is it B, C, or D? Give me some answers, people. Let me see. Okay, I got one person. Brianna, Bella, Camilla, Jacob. Why do you guys say B? What would be your evidence? If you're looking at, you're just going to tell me that organism B is most closely related to organism A. What evidence are you using? Yeah, the highest percentage. I mean, if we're looking and we're comparing organism D, only 50% of their DNA is similar to organism A. So that tells me that they're much farther off in common ancestry. Organism B is almost, well, I shouldn't say almost, but it's the highest, right? 97%. So when we're looking at DNA as a piece of evidence for evidence of evolution and common ancestry, the closer or the more the similarities in the DNA, the more closely related the organisms are. All right. So you guys are going to complete this POGIL as well. Let's see what's next on our calendar. The Edpuzzle is there. Phylogenetic trees. Phylogenetic trees. Where am I going? Okay. I actually really love phylogenetic trees. When you're looking at these, again, this is a way of looking at relationships amongst amongst organisms and their common ancestry. So every single time you see this line right here, okay, so they're telling you this is a common ancestor of all modern raccoons, pandas, and bears. So this means that they all share something in common right here. But at this point, hopefully everyone can see that these lines go in two different directions. And what that's telling us is that something changed so much so that they no longer shared this next common trait. Okay. So they shared a common trait here, but all of a sudden they diverge, meaning they move away. Divergence means to move away from. Now here, there's got to be another set of traits that are shared by all of these bears and pandas right here, okay? But as you move forward, again, you see, there's some sort of split that happens, a divergence event. So the giant panda is diverging away from all of its other ancestors. So here we've got one more trait that's shared by all of these bears, which, by the way, if we were in class, I would show you guys examples of all these bears. Please take a couple minutes and Google all of these bears because some of them are hysterical looking. So every single branching event indicates that these organisms have diverged from one another and they no longer share the next set of traits, whatever it is. Okay. So the closer organisms are in their branch, the more related they are. So we call each of these branches a clade, C-L-A-D-E. So polar bear, brown bear, that could be a clade. Black bear, polar bear, brown bear, that could be a clade. This entire thing right here could be a clade. It really just depends on what you're looking for. So you're going to use this to answer the questions. It's relatively short, so once you're done with that, you'll turn that in as well. Do I have any questions on any of that so far? Any questions? Nope. Okay. Let me put this in here before I forget. Create assignment. Oh my gosh. Typing is hard, sorry. Also, while I'm just sitting here, when you guys are doing your work on Google Classroom, you've got to make sure that you hit the turn in button. If you do not hit turn in, Google Classroom does not recognize that you did the work and I will not grade it. So before you do anything today, please go back and double check that you have hit turn in for everything so that you get credit for it. Even the Edpuzzle, hit turn in, and I have to go back to Edpuzzle and actually like double check scores and all that stuff, make sure you guys did it. But the Edpuzzles for the most part are going to be for credit, assuming that you at least passed. If you did not pass, I may have you redo an Edpuzzle, okay? Let's see. All right, so we got our phylogenetic tree, and then it looks like the last thing that you guys are going to be doing is your vocab words. Now you already did vocab, what was it? What did I have you guys do? How did I already forget my own assignment? Oh, you did 1 through 4. Okay, so you're doing what, 5 through 8? If you guys can be patient and give me a couple of hours today, I will grade your vocab that you've already done and I will return it to you. Once I return your document, you have editing access again. So you can do one of two things. You can do words 5 through 8 on a brand new document, which I will post for you, or you can wait until I return your vocab today and then you can continue to edit in the same document. Okay? Hopefully that makes sense. Does anybody have any questions on anything we just went over today? And you guys are all feeling okay. Oh, wait. Chicken dance, engage questions. It says it's missing even though I finished it. Okay, so the chicken dance, engage questions, and the Edpuzzle, those are the only two things that I can go and actually look and see if you did it or not. So if it shows on Google Classroom that it's missing, give me the next couple of days and I will put this stuff into Infinite Campus and then check Infinite Campus because the chicken engage questions and the Edpuzzle are the only two assignments that might show up as missing on Google Classroom, but they will show up in either the Edpuzzle or they'll show up in the Google Forms results. Okay. So remember that the purpose of all of the work that you guys are doing is to demonstrate that you understand evidence for evolution and that you understand evidence of common ancestry. Okay. So all of that will be posted, should all be posted as of right now, except the vocab words. The only other thing, I decided not to do a quiz today. I wanted to wait until we get the phylogenetic trees done. So I would anticipate probably having a mini quiz next Thursday. I don't know that we'll need to do a Google Meet next Tuesday since we're going over all the assignments right now. So that's why it was really important for you guys to be here today if you could. Go through, double check your classwork. Remember, code of conduct. Oh, you know what I forgot to tell you guys? If you can, when you're doing your assignments, do them in a different color font. And I think we tried to set it up that way for all of the documents, but there's certainly going to be some where I missed it. But if you do everything in a different color font, it's so much easier for me to see your answers and to get the grading done. Okay. So does anybody have any questions? Any questions? No, we're good? Yes, Katrina, there is a light on my headboard. Do you want look? Oh no, it's gonna look. Can you see it? Where's my camera? You see it lit up? Ah. I actually, those are new edition. I know, it's pretty awesome. It's so that I don't have to have all the lights on if I'm working on my computer or if I'm like reading or whatever. I know. There's one on the other side too. It's pretty awesome. Scott did it. I know. And actually, I was going to say, well, okay. Does anyone have any bio related questions? Uh-oh, Trinity's not on my remind anymore. Okay, Trinity. Hold on 1 second. Let's see. Okay, let me get Trinity the remind code and then okay, Trinity, here's the remind. Okay. What's the meaning of life? I can't help you there. Not today, at least. We'll need more time for that. Trinity, try that. If it still doesn't work, send me an email and I can add your cell phone number directly to the Remind app, but I don't want you to put it on here. Okay. So anybody else? Okay, perfect. Anybody else have any questions? You have until next Thursday to get those assignments done. Email me with questions. Give me until the end of the weekend to get Infinite Campus updated before you have, questions and concerns with that stuff. All right. Otherwise, I hope that you guys have a lovely weekend and let me know if you guys need anything. Okay. Okay. Bye.
Bye-bye.
Bye.